Hello everyone, I am Prabhash Vaddo, a senior physics teacher of cerebrosms in a national school and college. Today, I'm going to discuss about the evolution of a star. This is a bit new topic added to Edexcel O-level physics syllabus. So to talk about the evolution of a star, we'll know the lifetime of a star and how a star is formed and how a star dies. So first of all, we need to know how a star is formed. So if we look at the board, then we can see a star is formed from a huge cloud of dust and gas particles called a nebula. The gas clouds in a nebula contain hydrogen gas, and the gas particles are gradually falling towards the center of the nebula by gravitational attraction. The nebula becomes a much more dense structure called a protostar. So, the beginning of a star is nebula, and which is actually a combination of dust and gas particles. And the gas is the hydrogen gas. So, when the gas particles, that is hydrogen gas particles, are gradually pulled in towards the center of the nebula, that time the gravitational force increases. If we consider the hydrogen gas particles as scattered from a point, and when these gas particles are attracted, that time the GPE of gas particles, we can consider that the GPE of the gas particles is converted into kinetic energy because the distance between two gas particles are becoming less as they are pulled towards the center. So when these gas particles are becoming closer and closer, and this amount of these gas particles is much more greater, then these dense gas particles are commonly called a protostar. So this is the first stage of a star, and that is protostar. So this is the first stage of a star that will be evolved into different stages throughout the lifetime of a star. So after that means after the formation of a protostar, what happens we can see, that is the compressions of gas particles cause the gas molecules to increase speed and gas becomes very hot up to about 15 million degrees centigrade. So the compressions between the hydrogen gas particles increases their speed. That means increases the speed of gas particles, and the gas becomes very hot up to about 15 million degrees centigrade. Eventually, the great pressure involved also force the hydrogen nuclei together. When the compressions of the hydrogen gas started, At that stage, that will cause the great pressure, and so this force, and these will force the hydrogen nuclei together, and this initiates a nuclear fission reaction, fusing hydrogen nuclei to form helium. So, because of greater pressure, the hydrogen nuclei start to fuse together to form helium. And because of that, a very large amount of thermal energy is released, because this energy, heat energy, is released because of the nuclear fission of hydrogen nuclei. And this thermal energy generated prevents the protostar sinking anymore. Before that, we know that in protostar, gas clouds and gas particles were being pulled together, right? So they were becoming very closer by the gravitational force of attraction. But this time, when the hydrogen nuclei started fusing into helium nucleus, that time the protostar starts sinking. That means the protostar are not becoming very closer, right? Protostar particles are not becoming very closer. And these star then continues fusing hydrogen nuclei into helium nucleus for many millions of years until the hydrogen starts to run out. Thus, the star enters into its main sequence stage of life after the formation of photostar, and this main sequence stage ends when all hydrogen nuclei run out by fusing into helium nucleus. So the main sequence stage is the longest stable period of time in a star's lifetime. So first stage of a star is we call that is nebula, and after that, that is the protostar, and after the formation of protostar, the main stage of a star starts, and the life of a star is longest period in that stage. That means the main sequence stage of all the stages of the lifetime of a star is the largest. So what happens, we know that is the fission of hydrogen nuclei into helium nuclei. So that is the stage of main sequence. So after the end of this main sequence stage, what happens depends on a star's mass. So now we're gonna to talk about the star's mass and the consequent stages of a star's lifetime. So I think I need to raise the board to talk about the next stages of the lifetime of a star. So what happens after the end of the main sequence stage of a star depends on the star's mass. Our sun is currently in the main sequence stage and it has about 5 billion years left before the next stage. So what's the next stage after the main sequence stage? So this is called red giant. The next stage of a lifetime of a star after its main sequence stage is red giant. How it happens? Let's see. When stars with a similar mass to our sun start to run out of hydrogen, they start fusing helium. So as we're concerned about the happening before that, that means when the all hydrogen atoms at the core of the main sequence run out or completed or ends, so that time all the atoms are of helium atoms, right? Is in the core of the star. So after the fission of hydrogen into helium that happens in the main sequence stage, now the next stage starts through the fission of helium nucleus. So when the helium nuclei start fusing, that time the core of the star gets much harder and expands. So the star is now obviously in a stage which we used to say red giant, because in that stage, that means when the helium nuclei start fusing, that time the star appears red, because the observed surface temperature of the star decreases as the outer layers spread out. So it is called a red giant. After that, when the fission of helium ends, the outer layers are pushed away and the small core of the star collapses to become a white dwarf. So the stage next to the red giant stage is white dwarf. So the stages of the lifetime of a star, you can imagine very easily as it happens with the fission of hydrogen and next the fission of helium. So we can remember the stages of life very easily, because the main sequence, that is the fission of hydrogen, and next stage, that is the red giant. So in that case, there is fission of helium, and after that stage when the fission of hydrogen is also